Good morning all of you. Today I will start second unit in MFCS, set theory. In this unit subtopics are sets, relations, functions. So first topic is sets. So in this learning objectives are introduction about sets and operations on binary sets, principle of inclusion and exclusion. So what is a set? So in before classes in earlier stage we learn about sets. So we are all know the sets about natural number set, whole number set, set of integers, set of rational numbers, set of real numbers and set of complex numbers. In natural number set, the set starts with 1, 2, 3, 4 and so on infinity. In whole number set starts with 0, 1, 2, 3 and so on infinity. In integer set, 0 plus or minus 1 plus or minus 2 and so on infinity. The rational number set contains the form of p by q. Here q is the denominator not equal to 0 and p comma q are integers. So set of real numbers. So in this set the elements minus infinity to infinity. So in between any two numbers, decimal numbers are also belong these real number set. So set of complex numbers. In this set the number is of the form a plus ib. So here a is represents real number, real part and b represents imaginary part. These are the basic sets we know in earlier. So coming to sets. A set is defined as a collection of distinct objects of the same type or class of objects. The purposes of a set are called elements or members of the set. An object can be numbers, alphabets, names, etc. So what is a set? A collection of well-ordered or unordered elements, objects or things is called a set. A collection of well-ordered or unordered elements or objects or things is called a set. So the elements in a set must be in closed braces. The elements in a set must be in closed braces and an object can be numbers, alphabets, names, etc. So the elements in a set may be it is numbers, alphabets, names, etc. Okay. The elements in a set must be in closed braces or flower braces. Each element in a set is separated by comma. Each element in a set is separated by commas. For example, a set of rivers in India. A set of rivers in India. And another example, a set of vowels. So this set contains vowels in alphabets A, E, I, O, U. So this, for first example, this set contains all rivers in India. Okay. We broadly denote a set by the capital letters A, B, C, etc. while the fundamentals of the set by small letters A, B, X, comma, Y, etc. So if A is a set and A is one of the elements of A, so capital A represents set and small a represent the element of the set. Okay, then we denote it as A belongs to A. Here the symbol belongs to means element of the set, element of, that belongs to symbol. The symbol means element of. So what is a set? A collection of well ordered elements or objects or things is called a set. So the elements in a set must be in closed braces or flower braces. Each element in a set is separated by commas and set can be represented by capital letters and elements of the set can be represented by small letters. If an element is in that set is denoted by A belongs to A. So that belongs to symbol means element of the set. Element of the set. Okay. Next one. Sets representation. So representation of sets. We have two methods for representing the sets. So sets are represented in two forms. They are roster or tabular form, set builder form or rule method. So first method is roster or tabular form. Roster or tabular form. And second method is set builder form. So what is roster or tabular form? In this form of representation, we list all the elements of the set with braces and separate them by commas. So in the roster method, the set can be represented by enclosed braces. The set can be represented by enclosed braces and element in the set is separated by commas and element in the set is separated by commas. So let us consider an example. If A is equal to set of all odd numbers less than 10. So then in the roster form it can be expressed as, so here the given set is set of all odd numbers less than 10. Okay. Then in roster method, roster form, it can be represented by A is equal to the all odd numbers less than 10, 1, 3, 5, 7, 9. Okay. So what is roster method or roster form? The set can be represented by enclosed braces. The set can be represented by enclosed braces and element in the set is separated by commas. The element in the set is separated by commas. Okay. So second one, set builder form. So in this method, the set can be represented based upon property of the given elements. Property of the given elements. So in this form of representation, we list the properties fulfilled by all the elements of the set. We list the properties fulfilled by all the elements of the set. We note as X such that X satisfies property P and read as the set of those entire X such that each X has properties P. So that means in the set can be represented based upon property of the given element. Property of the given element. This method is called rule method or set builder form. Okay. So let us consider an example. If B is equal to 2, 4, 8, 16, 32, then the set builder representation will be, so the set builder representation of this given set will be X such that X is equal to 2 power n. Okay. X such that X is equal to 2 power n. So here X represents the element of the set. So the element of the set, the condition, the property of this set element is 2 power n, where n belongs to natural number set and n is between 1 to 5. Okay. This is the condition, this is the property for the element of the set B. So this is called set builder form. So what is tabular form or roster method? In tabular form, the set can be represented by enclosed braces and element in set is separated by commas. In set builder form, the set can be represented based upon property of the given elements. Property of the given elements. Okay. So types of sets. Next topic, types of sets. So sets can be classified into many categories, some of which are finite, infinite, subset, universal, proper, power set, singleton set, etc. So finite sets. So finite set means countable. So a set is said to be finite if it contains exactly n distinct element. So the number of elements in a set is countable. The number of elements in a set is countable is called finite. Otherwise it is called, what is called? Infinite. So a set is said to be finite if it contains exactly n distinct element where n is non-negative integer. Here n is said to be cardinality of sets. Here n is said to be cardinality of sets. The cardinality of sets is denoted by modulus A or the symbol hash A, card of A or n of A. Okay, cardinality of sets is denoted by these symbols. So what is finite set? The number of elements in a set is countable. The number of elements in a set is countable is called finite. So example, cardinality of empty set theta is 0 and is denoted by, cardinality means number of elements. So cardinality of theta is equal to 0 because empty set doesn't have any element. So sets of even positive integer is not a finite set because even integer set z containing elements 0, 1, 2, 3, 4, 5 and so on infinity. So that set contains uncountable number of elements. So sets of even positive integers is not a finite set. So infinite sets. So a set which is not finite is called as infinite set. A set which is not finite is called as infinite set, or the number of elements in a set is not countable is called infinite set. The number of elements in a set is not countable is called infinite. Okay, countable infinite, uncountable infinite. If there is one-to-one correspondence between the elements in set and element in natural number, a countably infinite set is also known as denumerable. So a countably infinite set is also known as denumerable. A set that is either finite or denumerable is known as countable. A set that is either finite or denumerable is known as countable. A set which is not countable is known as uncountable. So the set of a non-negative even integer is countable infinite. The set of a non-negative even integer, is called countable infinite. So next one, uncountable infinite. A set which is not countable is called uncountable infinite. Uncountable infinite set or non-denumerable set or simply uncountable. So for example, let us consider real number system. Real number set of all positive real numbers less than 1 that can be represented by the decimal form. So less than 1 and all positive real numbers. So the values is between 0 to 1. 0 to between all are decimal values. So 0.A1, 0.A2, 0.A3 and so on up to infinite. So where A1 is an integer such that 0 less than or equal to AI less than or equal to 9. Okay, this is example. So next another one, subsets. So next definition, another definition, subset or inclusion. Okay, so if every element in a set A is also an element of a set B, then A is called a subset of B. So it can be denoted by A subset are equal to B. Here B is called superset of A. So what is the definition for subset? If every A comma B are any two sets and every element of A is an element of B, then we say that A is subset are equal to B and B is also called superset of A. Okay. So for example, if A is equal to 1 comma 2 and B having elements 4, 2, 1, then A is the subset of B because the elements of A 1 comma 2 is an element of B. So all elements of A is in B, then we say that A is subset or equal to B. Okay, it can be represented like this, A subset or equal to B. So properties of subsets. Every set is a subset of itself. So first property, every set is a subset of itself because every element is in that set only. Okay, the null set, that is phi, is a subset of every set. The null set, that is phi, is a subset of every set. If A is a subset of B and B is a subset of C, then A will be subset of C. So A is a subset of B means every element of A is in B, and B is a subset of C means every element of B is in C. Then we say that A is subset of C. So if A subset or subset B and B subset C, then A subset are equal to C. A finite set having n elements has 2 power n subsets. If we are having n elements in a given set, the possible subsets of given set is 2 power n. The possible subsets of given set is 2 power n subsets. Proper subset. So proper subset. If A is a subset of B and A not equal to B, then A is said to be a proper subset of B. If A is a proper subset of B, then B is not a subset of A. That is, there is at least one element in B which is not in A. So what is the definition proper subset? Let A comma B or any subsets, let A comma B are any sets, and if A is a subset of B and B is not subset of A and B is not subset of A, then A is called proper subset of B. Simply say A is a subset of B and B is not a subset of A, then A is said to be proper subset of B. Okay. So for example, let A is equal to 2, 3, 4 and B is equal to 2, 3, 4, 5. So A 2, 3, 4. So A is subset or equal to B. When compared with B, every element of B not containing in A. So B is not subset of A. So then A is a proper subset of B. So what is the condition for proper subset? If A comma B are any two sets and A is a subset of B but B is not subset of A, then say that A is a proper subset of B. The null set phi is a proper subset of every set. So phi is proper subset of every set. Phi is proper subset of every set. Improper subset. So improper subset, if A is a subset of B and A is equal to B means B is a subset of A, then A is said to be an improper subset of B. So A is equal to 3, 4 and B is equal to 3, 4, then A is subset of B and B is subset of A and A is equal to B. So A is an improper subset of B. So every set is an improper subset of itself. So every subset, every set is an improper subset of itself. Okay. Universal set. If all the sets under investigations are subsets of a fixed set U, then the set U is called universal set. Then the set U is called universal set. So universal set means the set of all possible outcomes for the given task or given problem is called universal set. Okay. If all set of all possible outcomes for the given problem or given task is called universal set. It is denoted by mu or U. Okay. So example, in the human population studies, the universal set consists of all the people in the world. So the human population studies, The universal set consists of all the people in the world. Okay. Next definition, null set or empty set. A set having no elements is called a null set or void set. A set having no elements is called a null set or void set. It is denoted by 5. So, for example, 5 itself. Singleton set. It contains only one element. That set is called singleton set. It is denoted by singleton set S. Okay. So, S is equal to X such that X belongs to N and the condition is X is in between 7 and 9. So, the set containing the element 8. So, this is the example for singleton set. So, the set contains only one element. That set is called singleton set. Equal sets. Two sets A and B are said to be equal and written as A is equal to B if both have the same elements. Therefore, every element which belongs to A is also an element in B. Then, and every element which belongs to the set B is also an element in A. So, that is denoted by A is equal to B. So, X belongs to A is equivalent to X belongs to B. Then A and B are said equal sets. Okay. If there is some element in set A that does not belong to set B or vice versa, then A not equal to B, that is A is not equal to B. So, when we say that given sets are equal, every element of A is an element in B or every element of B is an element in A, then we say that A and B are equal sets. If any element of A is not belongs to A, then we say that A not equal to B. Next one, equivalent sets. Equivalent sets means the cardinalities of two sets are equal. They are called equivalent sets. So, the number of elements of two sets are equal, then we say that the two sets are equivalent. Okay. So, if A 1, 2, 6 and B is equal to 16, 17, 22, they are equivalent as cardinality of A is equal to the cardinality of B. Cardinality means number of elements of A is 3 and number of elements of B is 3, then that is cardinality of A is equal to cardinality of B is equal to 3. So, the number of elements of A is equal to number of elements of B, then we say that A and B are equivalent sets. Okay. So, disjoint sets. Next one, disjoint sets. If sets A and B are said to be disjoint if no element of A is in B and no element of B is in A. So, both sets are having different elements, that is it. So, two sets A and B are said to be disjoint if no element in A is in B and if no element in B is in A, then we say that A and B are disjoint sets. So, for example, R and S are two sets and R having elements A, B, C and S having elements K, P, M. In these sets, any two elements are not equal. Okay. So, R and S are disjoint sets. This type of sets is called disjoint sets. Power sets. Next definition, power sets. The power of any given set A is the set of all subsets of A and is denoted by P of A. If A has n elements, then power of A means P of A has 2 power n elements. So, the all possible subsets of given set, the set of all possible subsets of given set is called power set. The set of all possible subsets of given set is called power set and it is denoted by P of A. So, for given set the possible subsets are 2 power n possibilities. Okay. So, if A has n elements then P of A has 2 power n elements. So, A is equal to 1, 2, 3. The possible subsets of this is 2 cube means 8 subsets. The set of that 8 subsets is called power of A. So, first empty set is subset of every set and singleton set 1, singleton set 2, singleton set 3 and set of 1 comma 2, set of 2 comma 3 and set of 3 comma 1 and every set itself is a subset. So, set of 1 comma 2 comma 3. These are possible subsets of given set A. The set of these subsets is equal to power of A, power set. So, power set of A. So, what is the definition for power set? The possible subset, the set of possible subsets of given set is called power set. Okay. If the given set has n elements, then the possible subsets of given set is 2 power n possibilities. Okay. Next one, partitions of a set. Partitions of a set. So, let S be a non-empty set. A partition of S is a subdivision of S. A partition of S is a subdivision of S into non-overlapping and non-empty subsets. Specifically, a partition of S is a collection of AI of non-empty subsets of S such that each A in S belongs to one of the AI. Each A in S belongs to one of the AI. The sets of AI are mutually disjoint, that is AI not equal to AK, then AI intersection AK is equal to 5. The subsets in a partition are called cells. So, what is a partition of a set? So, S be a non-empty set. So, S be a non-empty set and a partition of S is a division of S into non-overlapping or non-empty subsets. Specifically, a partition of S is a collection of AI. Here, each A in S belongs to one of the AI. The set of AI are mutually disjoint, that is AI not equal to AK, then AI intersection AK is equal to 5. So, Venn diagram of a partition of the rectangular set S of points into 5 cells A1, A2, A3, A4, A5. So, here A1, A2, A3, A4 are disjoint sets. The set of these sets is called partition of S. So, here the representation of Venn diagram for partition of a set is, so each partition is called cell. Okay, each partition are called cell A1, A2, A3, A4, A5. Thank you.